All right, so let's look at some nonlinear inequalities. Okay, nonlinear means that there's exponents other than just 1 on the variable, and inequality has a greater than, less than symbol. All right, if you remember, there's basically, I would say, 3 main steps to solving inequalities like this. So the 3 main steps, you want to set it equal to 0 or get 0 on one side of the equation. Then you want to find the zeros and the undefined numbers and plug in the numbers in between. Okay, when you do that, plug in the numbers in between, you can tell which sections of the number line are going to be positive or negative. All right, so to get 0 on one side, we have positive 3. We're going to do negative 3. On the left, we have 2x squared minus x minus 3. Here it cancels, and that's greater than or equal to 0. Now, in order to find the zeros when this actually equals 0, we have to factor this. All right, so let's see. You can use factoring by grouping, but I think this one you can do it just manually. To get 2x squared, the first terms would have to be 2x times x. And to get negative 3, the only factors for negative 3 are either negative 1 times 3 or 3 times negative 1. So let's see. We want the numbers to add. When we do the inner-outer, we want to get negative x. So let me see. If I put a 3 here and a 1 here, I can get 3x and 2x. And we want negative x, so I'll put a negative 3 here and a positive 1 here. All right. Negative 3 times x is negative 3x, plus 1 times 2x, that's 2x, so negative 3x plus 2x gives us negative x. And the last negative 3 times 1 is negative 3. So that's it right there. You set each one of these equal to 0. So 2x minus 3 equals 0. 2x equals 3. And dividing both by 2, one of the zeros is going to be 3/2. Here, if we do x plus 1 equals 0, minus 1 on both sides, that's going to be x equals negative 1. Okay, by the way, if you couldn't do that factoring, you should do the con exercise factoring by grouping. So let's do a number line here. The smaller or negative numbers are going to be on the left. So we have a negative 1 and we have a 3/2, which is the same as 1.5. All right, and let's plug in numbers that are in between the zeros. So the easiest one in here is going to be x equals 0. The easiest one over here is going to be x equals 2. And the easiest one over here is going to be x equals negative 2. All right. So see that? We're plugging in numbers in between the zeros. And I am going to plug it into the factored equation. It's a little bit easier in my opinion. All right, so let's see. I'm going to bring this down here. And we'll start with f of negative 2. So we're just plugging in negative 2. And we only need to say if it's negative or positive, really. So plugging in negative 2, we have 2 times negative 2. That's negative 4 minus 3, that's negative 7. And negative 2 right here is going to be negative 2 plus 1, that's negative 1, that's also negative. So it is positive in that section right here. Next up, f of 0. All right, so we're plugging in 0. And right here we would have 0 minus 3, that's negative. Right here we would have 0 plus 1, that's positive. Negative times positive is negative. Finally, f of 2. All right, we already did f of negative 2, and now we're going to do f of positive 2. Positive 2 times 2 is 4, minus 3 is positive 1. And 2 plus 1 is 3, that's positive. Positive times positive is positive. So this section is positive. Now, what do we want? The positives or the negatives? Well, let's see. Right here, it says that this equation has to be greater than or equal to 0. So in other words, this thing right here has to be positive or 0. Okay, so the values at the zeros, that works. The 1.5 is good, the negative 1 is good, and everything that's positive is also good. All right, so in other words, everything greater than or equal to 1.5 would work, and everything less than or equal to negative 1 would work. All right, if you go to the left, that goes to negative infinity, and if you go to the right, that goes to positive infinity. So in interval notation, you start at the negative infinity, use a comma, and it goes to negative 1, and it includes negative 1. It's greater than or equal to, so on the negative 1, you use the square, but on infinity, you always use the rounded. And that is in union with 1.5, it's greater than or equal to, so the 1.5 is included, comma, and that runs all the way to infinity. All right, you use the rounded on infinity. All right, so that's your answer right there. If you wanted it in normal notation, it would be x is less than or equal to negative 1, and x is greater than or equal to 1.5. I guess you use the word and here. But on the test, I'll do the interval notation. All right, for this type of inequality here, it's the same thing, but you're going to have to get a common denominator. But the first step is still the same. We want 0 on one side, so I'm going to do minus 2 on both sides here. So all right, minus 2 on both sides, we have x minus 4 over x plus 5, and that's minus 2. Leave some space for the fraction, and that's going to be, this cancels here, so that's going to be greater than 0. Now, what do we do with this negative 2? Well, we need a common denominator. The denominator here is x plus 5. So I'm going to multiply this by x plus 5 over x plus 5. Why am I allowed to do that? Because this is the same as 1. Negative 2 times 1 doesn't change the value. Okay, rewriting, x minus 4 is the numerator. X plus 5 is the denominator. And this right here also has the denominator of x plus 5. So we have a common denominator distributing negative 2 times x and negative 2 times 5. All right, and that's greater than 0. All right, combining like terms, x minus 2x is negative x. Negative 4 minus 10 is negative 14. And that whole thing is over x plus 5. And at this point, I don't want to confuse you, but I'm going to set it equal to 0 just in order for me to get the zeros and the undefined terms. We have to do both of those. All right. Remember, that was in the 3 steps at the beginning. So for the zeros, that's when the numerator equals 0. Okay, negative x minus 14 equals 0. And if I do plus x on both sides, negative 14 equals x. And for the undefined, that is when the denominator equals 0. We know that can't be true. So if the denominator or the x plus 5 would equal 0, that's undefined. If I do minus 5 on both sides, that's a negative 5. All right, on the number line, what do we have? We just have negative 14 and negative 5. Okay, the more negative you go, the more to the left it is. Okay, and now we want to plug in values in between. The best one in between, I'm going to go with x equals negative 10. And greater than negative 5, I'm going to go with x equals 0. And less than negative 14, and we can do negative 15. We could even do negative 20. Okay, it's just anything less than negative 14. All right, so these are my test points. I'm going to test each one, and we don't care what the result number is. We only care if it's positive or negative. All right, so let's see. We may have started with this, but this is the simplest one. All right. That's the simplest one to plug in my opinion. All right, so let's start with x equals negative 20. All right, you can also write f of negative 20, same thing. So if we put a negative 20 in here, that would be the negative of negative 20. That's positive 20. Minus 14, that's positive 6. Negative 20 plus 5 is negative. Positive over negative is negative. Okay, so in this section, that's negative. In here, let's do negative 10. The negative of negative 10 is positive 10. Minus 14, that's negative. Negative 10 plus 5 is negative. And negative over negative is positive. And finally, x equals 0. Zero minus 14 is negative. 0 plus 5 is positive. So that's negative over a positive. And that's negative. All right, so that's what we're looking at. In that section, it's going to be negative. And what are we looking for? Well, we want this mess right here. We want that to be greater than 0. So this has to be positive, okay? It can't equal 0, it's just greater than 0. So this has to be positive. So we are looking at the positive section. It is not equal to 0, so it does not include the negative 14 and negative 5, but it includes everything in here. So negative 14 is on the low end, x is in the middle, and negative 5 is on the high end. X is greater than negative 14 and less than negative 5. In interval notation, it runs from negative 14 to negative 5. Does it include either one of these? No, it's not equal to. So in both cases, you're going to use the rounded parentheses. And that is the final answer, interval notation. All right, one more. As always, you want a 0 on one side of the equation. The opposite of -1 is +1. Cancels right here. We have x squared minus 3x divided by x plus 1, and that's +1. Leave some space for the fraction, and that's going to be less than or equal to 0. All right, we need a common denominator. So our denominator is x plus 1. I'm going to multiply by x plus 1 over x plus 1. All right, so our common denominator is x plus 1. And we have x squared minus 3x. And distributing this 1 changes nothing. It's still going to be x plus 1. So that is also over the common denominator of x plus 1. And that's still less than or equal to 0. All right, combining the likes, -3x and +x is -2x. We still have x squared, and we still have +1, and that's over x plus 1. And at this point, I'm going to set it equal to 0 because we need to find the zeros and the undefineds. All right, so we'll do the zeros and the undefineds. The zeros are when the numerator equals 0. So if we have x squared minus 2x plus 1, we need to factor that. All right, we need two numbers that multiply to 1 and add to -2. If we write out the factors for 1, that's either 1 times 1 or -1 times -1. That adds to -2. So it's basically x minus 1 times x minus 1 equals 0. All right, either one of these can equal 0. So basically, x is just 1, because 1 minus 1 is 0. For the undefined, that's when the denominator equals 0. And minus 1 on both sides, you have x equals -1. All right, we're going to put these on a number line, and we're going to plug in the numbers in between. All right, on a number line, -1 would be on the left and +1 on the right. All right, and what are the easiest numbers to plug in? In between 1 and -1, I'm going to go with 0. Greater than 1, I'll go with 2. And less than -1, I'm going to go with -2. All right, let's start with the -2. And where is the simplest form of the equation that we can plug in? This one right here. All right, this is the simplest form. It's the same as the original. All right, it's the same as the original, but I would rather plug in the simplest one. So let's see, we're going to start with -2. All right, x equals -2. And what do you get? Negative 2 squared is 4. Negative 2 times negative 2 is 4. 4 plus 1 is positive in the numerator. Negative 2 plus 1 is negative. So positive divided by negative is negative. So on that section right here, that's a negative. Next up is x equals 0. All right, 0 minus 0 plus 1, positive. 0 plus 1 is positive. We have positive over positive. So that's positive. And the last one, x equals 2. All right. Going down here, x equals 2. If we put in a 2, 2 squared is 4. Minus 2 times 2, that's negative 4. That's 0 plus 1 is positive. And then over here, 2 plus 1 is positive. So that's positive over positive. So that is also positive. All right, so that section is also going to be positive. So which section do we want, the positives or the negatives? We'll go back to the original. All right. And for the part with the 0, it is less than or equal to 0. All right. In every case, it's less than or equal to 0. So this mess right here since it's less than 0, it's either going to be negative or it's going to be 0, either one. All right, so let's look for that on the number line. That's this section right here. It includes the negative 1. Let me make sure, was the negative 1 a 0? No, it was not. The negative 1 was undefined. So we do not include the negative 1 because that was not 0. That was making it undefined, but it's everything less than that, all right, because it's the negative part. So basically, x is less than negative 1. In interval notation, it runs from negative infinity to negative 1 with a rounded parenthesis on each, because that undefined point is not a 0. That's just undefined, so it doesn't count.